Okay, so looking at 10.5, apply other angle relationships in circles. So we're still looking at angles. Okay, we'll look at chords in the very last section, but we're looking at angle measures in this one. So the first one that we need to look at is if you have a tangent line and a chord. So here's our tangent line right here. Here's our chord. And they intersect each other right on the circle. So where they cross each other and overlap each other is right on the edge of the circle. Then the measure of each angle formed is half whatever the arc is. So those two, the segment and the line, create two angles. We have angle 1 over here, and we have angle 2 over here. And they're equal to whatever half the arc is. So the equations that go with that, it would be angle 1 is equal to 1/2 of the measure of the arc AB. It's open up to AB. Angle 2 would be half of the other arc. So half the measure of BCA. So if there was a 100 on the arc, you would just cut it in half. That's your angle measure. So this is just like the inscribed angles. If this was 50 out here, this would be 25. Same rule for this. The angle is pulled all the way to the back edge of the circle, so it has that same property. You learned that one in the previous section. So this would be an example of a test question. So if you have a circle, okay, we have this tangent line here, we have a chord, and then we have angle 1 right here, and they want to know what is the measure of angle 1. And they told us that this arc right here is 140. How big is angle 1? Agree? 70? Okay, so the measure of angle 1 is half of whatever the arc is. You're going to see a lot of half. A lot of times, almost all of the equations have a 1/2 in them. The angle ends up being half of some of the arcs. Any questions? Anyone still need this? All right. So there are 3 different ways that 2 lines can intersect in a circle. And I've highlighted the specific differences in these 3. So those red dots right there can either be on the circle, in the circle, or outside of the circle. So if you could get these 3 pictures down, we're going to get formulas for each one. And you'll want to get all those same letters down as well, because that's how our formulas are going to work underneath each one. So the first one is actually just simply an inscribed angle. I'm going to jump right back to this. But that first picture is just like this one right here, where we have an angle that's all the way to the back of the circle. So the measure of angle 1 is going to be what? 1/2 of whatever AB is. So 1/2 the measure of AB. So it's just half of the arc. So if it's 100, it's 50. If it's 50, it's 25. You just cut that arc in half. These next two are going to be new, and they are on the formula sheet that I gave you. So on this middle one, when they intersect inside, they create two arcs that it's open up to. Okay? Now, you would agree that vertical angles are still congruent. So this is just like angle 2, and whatever this is also angle 3. They're the same measure, correct? Okay? So whatever they're open up to are the arcs that create that measure. So again, there's a 1/2 on both of them. And since it creates two arcs, we have to put those two arcs together. We're going to add them together. So angle 2 is open up to this top arc and also the bottom arc, correct? That's kind of what it's open up to. So we're going to add those two arcs together. So WZ and then the bottom one, XY. So whatever those values are, you add them together and times it by 0.5. Angle 3 is open up to the left and the right arcs. So that's WX and ZY. So whatever the angles are open up to, you add those arcs together and cut it in half. And that will give you the angle measure. Questions on that? Now, if they intersect outside of the circle, it still creates two arcs that it's open up to. Do you see that? There's one here and there's also one right here. Now, when it intersects outside the circle, the only difference is instead of adding, we're going to subtract on those. So if it's outside the circle, we still have a 1/2. We still have the two arcs, EF, and we're going to subtract from it CD. Now, somebody tell me, why did I put the EF first? And it's the bigger arc. We don't want negative angle measures. Okay, so you subtract the big arc minus the little one. Questions? The way that I remember the difference between the plus and the minus is if you look up here, when it's inside, it looks kind of like there's a plus sign turned on its side right there. A plus sign inside the circle. That's how I remember that that one's the one that you add. This is the one that you subtract, because if you look inside the circle, it looks like two minus signs. That's how I remember. Okay? Because that's the only difference between the two. Is that on one you add and the other you subtract. Okay? We're going to do some examples in a second, but are there questions on the formulas? Does anyone still need this page? Okay, so I would like you to draw these three pictures. Just get dots on them where I have dots. So 3 circles. Mm-hmm. These aren't new formulas, I'm just clarifying a few things. Because all of these are lines intersecting outside the circle. So we're still going to subtract our arcs, just like we learned on the previous one. And we're going to put some numbers and letters on here. So we'll do this as angle 1, this is angle 2, and that's angle 3. Then we'll just go through the alphabet. So this will be A, B, put them on the same spots I am, please. C, D, E, F, G, H, I. So we're just going to write the formulas for each of these. Now, it's the same as this last one that we did, because all of these are two lines intersecting outside of a circle. So it's all going to be this one down here, the one that's behind. It's all this 1/2, and then you subtract your 2 arcs. Okay, so let's figure out what 2 arcs we're looking at. So this one will be angle 1 is equal to 1/2. We're going to subtract 2 arcs. What 2 arcs are we going to subtract? What does it open up to? CD minus AB. Because notice that here's one of the arcs that it's open up to, there's one of the arcs that it's open up to. Okay, looking at this one, what 2 arcs does it open up to? This is angle 2 is equal to 1/2. What 2 arcs? EG and FG. So we have this arc, whatever number is on there, minus that smaller arc. They'll give you numbers on those arcs. You're just going to put them into the formula. This last one, let's put another point out here and put a J on there. Angle 3 is equal to 1/2. We're going to subtract 2 arcs. No. HJI, because we need to go all the way around here. That's the big arc that it's open up to. And subtract away what? And subtract away the little one. Questions before we try a couple examples? All right. Let's try looking at these 2 first. So I'll give you some time to draw these. We've got 4 examples, and again, we're not doing homework today. We'll do that tomorrow. So this is our task for the hour. So once you get your picture, you're always going to be asking, which formula should I start with? You always want to kind of get your skeleton written, and then you can put your numbers in where they go. Just remember that on all of the equations, it's going to be angle is equal to 1/2 and then arc or arcs, depending on what picture you have. It may just be 1 arc or maybe 2 arcs. You're going to add or subtract. But you're always going to have an angle on one side and your arcs are put together. You're never going to put an angle with an arc. They stay separate, one on each side of the equal sign. So, looking at this first one, we've got an angle, remember, over here. So we're focusing on X, which is open up to these 2 arcs, right? Okay, we don't have anything on those arcs. We do have stuff on the other 2 arcs. So because of that, we could find that angle right there, which would help us find X. So let's try to find Y first. Are we going to use one where we add the arcs or subtract the arcs? Add, because it looks like a plus sign inside the circle, right? So we've got our angle, which is Y, 1/2. What arcs are we going to add together? Okay, so we put that in the calculator. What answer do we get? Did you times it by 1/2? Positive?
I think so.
Okay, so 124.5 would go right here, right? So how would we figure out what x is? Because that's what we want.
You do 124 plus 124, and I get that, but then minus 36 divided by 2.
You can do it much quicker by doing what?
180 minus 124.
Yes, these are on a line together. So 180, your way would have done it. It would have gotten it right. 180 minus 124.5, and we get 55.5. So that would be that answer right there. What is it? Is that right?
Yeah. I just said it was good that it wasn't 66.6.
Okay. This one right here. Are we going to be adding or subtracting on this one? All right. So we've got angle. What's our angle?
70.
And then we have arc and arc. So what is the order?
55 plus x, or x plus x minus 55.
X, the big one, minus the small one. What should we do? Yep, we can distribute. 70 equals 1/2 x minus what? 27.
Yes.
Okay. Now what?
Plus 27.
Mm-hmm. So we've got 97.5 equals 1/2 x. What's the last step? Not divide by 2. You can either multiply by 2 or you can divide by 1/2. Both will get you the same answer. No. Needs to get way bigger. 97.5 divided by 1/2 is a big number. What is it? How much? Okay, so that would go here. Okay, 2 left. Add or subtract on this one? Okay, we have angle and then 2 arcs. So which one's the angle? X on this one. 1/2. What am I subtracting? Someone punch that in. That one's a quick one. Into your brain, what do you get? So what do we get? Times by 1/2? This would be so much faster if we would just put this in. What is it? No.
It's 319. It's 319. It's 55. 50.
What is it? Okay, the last one we'll do tomorrow before homework.